Welcome to the Maynooth University Virtual Open Day. I hope you're all doing well given these rather challenging circumstances. My name is Mark Walsh. I'm a lecturer in mathematics at Maynooth University, and I'm going to just say a few words to you about mathematics and in particular mathematics at Maynooth. Before I say anything about mathematics itself, I would like to just give you a very brief overview as to the kinds of programs we have in mathematics at Maynooth. Essentially, these fall under three categories. There's pure mathematics, applied mathematics, and mathematical studies. Pure mathematics can form part of either a science or an arts degree. Usually these are three-year programs, although within science, you can also take pure mathematics as part of a four-year general science degree. This is particularly nice for students who perhaps at the second level didn't realize that they were interested in mathematics as a specialization. So it's still possible, even if you begin a general science degree without considering possibly mathematics, to switch into mathematics as a major, as either a single major or as a double major with some other science subject. Applied mathematics is taken as part of the general science degree over 4 years. And finally, mathematical studies. This degree is taken in arts, and it's typically aimed at students who are interested in fulfilling the teaching council requirements for second level teaching. So the mathematical studies degree fulfills all of those requirements. The question, what is mathematics, is actually a surprisingly difficult question to answer. Over the centuries, many great thinkers, philosophers and mathematicians and writers have grappled with this question and tried to provide some kind of coherent definition as to what precisely mathematics is. Some have seen mathematics as a kind of a language of nature or a language of science, a study of patterns and symmetries. The ancient Pythagoreans believed that everything in the universe could be reduced down simply to numbers. I'm not sure I agree with that statement, but it is surprising how many places mathematics arises in nature, in science, in art and architecture, in music, and so on. So rather than trying to give you any kind of definition as to what mathematics is, I will, over the next few slides, just provide you with a few examples of the kinds of places that mathematics arises in. Art is filled with examples of mathematical and in particular geometric intuitions. The Alhambra in Spain, which at one time was a mosque and later a Christian church, is filled with beautiful examples of Islamic art, patterns with all sorts of wonderful symmetries, and a great deal has been written about the kind of mathematical connections the Alhambra contains. The Book of Kells, an example from Ireland, has all sorts of wonderful examples of Celtic art, Celtic knotwork, and so on. So this is something that is part of Irish culture as well. In nature, we see examples of mathematics. On the left here, we see a nautilus shell. This is an example, mathematically speaking, of a shape called a logarithmic spiral. And at one level, we have this spiral in the nautilus shell, and then at a completely different level, we see examples of this kind of mathematical shape in a spiral galaxy. Music and also architecture are two other places where mathematics arises. The ancient Pythagoreans noticed that if you took a string of a fixed length and you plucked it, then the note you obtained was exactly one octave lower than the note you had obtained by plucking half the length of that same string. And from this observation, they created a whole system of what are called Pythagorean harmonics, interesting ratios in lengths of strings and so on, and different kinds of notes and harmonies you can achieve by plucking strings of certain fixed proportional lengths. The picture on the left-hand side gives some indication of what's going on there. In architecture, we see wonderful examples of symmetry and ratio also. The Parthenon in Athens, and I've provided here a picture of a replica of the Parthenon, which was built about 100 years ago in Nashville, Tennessee, describes or provides all sorts of interesting examples of symmetries and is based very much on an important mathematical constant known as the golden ratio, something that's well worth looking into.
As I'm sure you're aware, mathematics is also a very, very old subject. Most of you heard, for example, of the theorem of Pythagoras, and Pythagoras, somewhat legendary figure, probably lived about 500 BC. But just to give an indication as to how old this subject is, the most famous theorem associated with Pythagoras, his theorem concerning right-angled triangles, was actually understood pretty well many, many, many hundreds of years beforehand. In fact, going back to 1800 BC, there are tablets written in cuneiform from Mesopotamia which give information concerning the Pythagorean formula. These are some examples translated on the right-hand side. These numbers 3, 4, 5, and then 5, 12, and 13, these are what are known as Pythagorean triples. These are numbers which fit together in the form of a right-angled triangle satisfying Pythagoras' famous theorem. One of the most famous examples of the power of mathematics is a calculation that was done by Eratosthenes in around about 250 BCE. Eratosthenes was the chief librarian at the great library in Alexandria, which is in modern-day Egypt, and using just very, very simple geometric methods was able to approximate the circumference of the Earth at about 40,000 kilometers, which is essentially the correct answer. And this was back, as I said, in 250 BCE. This involved some simple observations concerning shadow lengths from arising from sticks pointing vertically out of the ground, looking at how the sun fell on these sticks at different locations on the Earth, and noticing that the difference in shadow lengths could only be explained by curvature of the Earth. But that was only one part of this. The really impressive part was he was able to use geometry, very simple trigonometric methods, to actually use these shadow lengths to very, very accurately approximate the circumference of the Earth. It's a remarkable achievement and a remarkable tribute to the power of mathematics to draw conclusions about the world around us. Mathematics contains objects of extraordinary beauty and complexity. I don't want to go into too much detail on this, but this particular example, the Mandelbrot set, arises from a very, very simple equation. And so by just following some very, very simple rules, you develop this object of astounding complexity and beauty and intricacy. This is something which is replete throughout mathematics. You'll find all sorts of examples of this kind of thing, where from some very, very simple rules, simple origins, you can obtain extraordinary complexity and extraordinary beauty. I find this kind of thing inspiring, and perhaps some of you might find it inspiring too. If you're interested in this, mathematics is certainly the subject for you. It's worth mentioning, although this is maybe not quite as inspiring as the previous slide, it's worth mentioning that mathematics actually does a great deal to enhance your career prospects. This is a short clip from a Wall Street Journal article from a few years ago, which ranks various professions. And as you can see, mathematics comes out on top. There are all sorts of reasons for this. As a mathematician, I have to say I find my job extremely satisfying. I love getting up on a Monday morning because I get a chance to do mathematics and to teach mathematics. And there are all sorts of other professions involving mathematics which are equally satisfying and equally rewarding. So it's for all sorts of reasons that I would recommend mathematics to you, but if for nothing else, career prospects are certainly an important aspect of this, and mathematics does very, very well as a career choice.
So why Maynooth? Well, the Department of Maynooth covers a wide range of different mathematical areas. We have faculty working in algebra, number theory, geometry, topology, various kinds of analysis, some applied mathematics, and also mathematics education. So there's a good deal going on in the department. And I should point out that this is active research, internationally recognized research. We have faculty who obtain their doctorates in top international universities and who publish in some of the world's leading mathematical journals. So we have an active research program going on, and it's very, very beneficial for students to interact with faculty who are actually doing mathematical research in real time. Our approach is very much student-centered. We provide a great deal of support to students. One example of this is a dedicated mathematical support center on campus, where the university will provide tutors for students to help them with various mathematical problems. And trust me, we all have lots of mathematical problems, and every now and then we all need some help. The ratio between student and faculty is very healthy. If students want to come into the department and talk to faculty members and ask questions, they will find it very easy to get help from faculty. And in general, from my experience at least, faculty in the department are only too willing to stop and talk to students about mathematics, essentially at the drop of a hat. So I think the department at Maynooth is friendly. It's a very nurturing department. It's a really good place to obtain a training in mathematics, and it would set you up very, very well for any kind of mathematical career later on. All right, with that said, I will let you go. I thank you very much for joining me on this virtual tour in these rather difficult circumstances. I hope you're all doing well and staying safe, and I look forward to hearing from any of you who are interested in finding out more. Please feel free to email me. You can find my email address on the Mathematics Department webpage, but just in case you can't, it's mark.walsh@mu.ie, and I'm very happy to answer any further questions that you might have. Okay, thank you very much. Bye-bye.